Now, a lot of the things that we've been doing with addition are not difficult, but they're time-consuming and error-prone, and we'd like to have a way to catch it if we make a mistake. We can check our work in arithmetic by estimating the result. What do I mean by that? To estimate the result, first, we round the given numbers, and then we perform the arithmetic with the rounded numbers. And finally, if we're using this to check our work, we see if the result is close to the one we got. This will become clearer when I show you an example. Right, let's suppose we've just done some addition. Let's say we've just done this addition and we think that our answer is 5,696. Now some of you might be immediately saying, no, don't do that, the answer is wrong. Right, which is cool. But probably if you're doing that, you're doing something like the check I'm about to show you in your head. So here's what we're going to do. First, we're going to round the smaller number to have one non-zero digit. This is the smaller number in that. If I want to round it to have one non-zero digit, that means I'm going to round it to the hundreds place. Well, okay. So this number is between 800 and 900. The 7 tells me it's closer to 900. Okay, so that's how I round the smaller number. Now I'm going to round the bigger number to the same place. Why am I making this choice? You'll see why when I do the addition. Right, I rounded the smaller number to the hundreds place. I'm going to round the bigger number to the hundreds place. This is between 5,800 and 5,900. The 2 tells me it's closer to 5,800. Okay, now why did I choose exactly that rounding? Now I'm going to write these numbers to do addition, right, because I want to do the same operation that I did in my original problem, right? Okay, now why did I choose to round the way that I did? Do you see how I've got a bunch of zeros off to the right here? There's no work to do with all these zeros. It's all 0 plus 0 is 0. The only place I have work to do is in this first place that I rounded to. I only have to really do work in one place. That's why I chose to round this way. This problem is much easier than this problem. That's what makes it a good check. All right. So I've got to do 9 plus 8 is 17. Oh, 5 carry the 1, 6. 6. What do you think? 6,700? Is that about the same as 5,696? No, I bet I did something wrong. In fact, let's try working this problem again. If I'd just done this problem and I had the work in front of me, I might like pull the work out and try to figure out what I did. Or I might just say, let's do that again. 1 and 5 is 6. 2 and 7 is 9. 8 and 8 is 16. Oh, I bet I know. 5 and 1 is 6. Yeah. What did I do wrong the first time I worked this problem? Yeah, I forgot to carry the 1. But I caught my mistake because I checked. So I know that this answer was wrong. And I actually get 6,696. 6,696, that's real close to 6,700, isn't it? It's like 4 away. So I know that this worked out really well. Okay. So I'm going to have you do an exercise where you just estimate the sum. Using this method, round the smaller number to one non-zero digit, round the bigger number to the same place. Pause the video and try this now. Okay, so let's see. This is the smaller number. If I want to round it to have one non-zero digit, that means I want to round it to the thousands place. 3,251. That's between 3,000 and 4,000. The 2 in the next place tells me it's closer to 3,000. If I rounded this number to the thousands place, I also want to round this number to the thousands place. 52,629. That's between 52,000 and 53,000. The 6 in the next place tells me it's closer to 53,000. Okay, so to estimate the sum then, I'll add 53,000 plus 3,000. Again, I don't need to think at all about these columns with just zeros in them. 3 and 3 is 6. 5 and nothing is just 5. This sum is about 56,000. For the sake of the exercise, if you'd like, you can add these two numbers and see how close the answer really is to 56,000.